afternoon, everyone. I'm delighted to welcome the more than 500 participants with us this afternoon in this one-of-a-kind, no doubt thought-provoking program held at a very particular moment in time. Today is International Women's Day, as many of you may know, and it's also the eve of the launch of Walter Isaacson's new book, a book that details the journey of Nobel Prize-winning scientist and technology pioneer, Jennifer Doudna. I'm Susan Paley, NACD's Vice President of Chapter Network. And if this is your first NACD chapter experience, I do hope you'll make it the first of many. And if you've participated in our chapter programming in the past, welcome back to you. And I look forward to seeing you again at one of our 350 programs produced each year by this network. It's never been easier than it is now in this virtual environment to keep up to date with your own professional enlightenment, as well as peer-to-peer dialogue with other boardroom leaders. And as a boardroom member, or pardon me, as an NACD member, you have access to all chapter programs at NACD. I'd like to thank today's speakers and sponsors, our chapter leaders and hardworking staff, as well as our members and today's special guests for joining us virtually today. I remember just 3 years ago when I sat in a packed conference room with more than 1,500 directors at our annual NACD Summit, listening to Walter Isaacson share his insights on his new book, at the time, Leonardo da Vinci. You could hear a pin drop in the room. And I think I speak for every member of that audience when I say we couldn't wait to see whom he would highlight and bring to center stage with his pen in his subsequent works. And on such a special day as this, when we celebrate pioneering women, it's indeed fitting that the subject of Walter's newest book is a woman. As most of you here know, NACD is the recognized authority on leading boardroom practices, helping over 21,000 directors elevate board performance for more than 40 years. We're fortunate that both our distinguished speakers today are also corporate directors and governance leaders. I trust this discussion will help us to thoughtfully consider tomorrow's challenges as they relate to any number of matters, not the least of which is public health. In just a few minutes, we'll meet our speakers for the main program. And a note to our audience that the Q&A portion of this program will be facilitated by my friend and colleague, Judy Warner, who is our editor-in-chief of NACD's Directorship Magazine. I know Judy will do her best to ensure that we get to as many questions as possible in our limited time today. Today's program and VIP reception are presented with the support of our tremendous sponsors, Baker Botts, Lockton Companies, and Bank of America. We were delighted that each audience member has received a copy of Walter's new book, The Code Breaker, delivered right to your doorstep. And we want to emphasize that gift was made possible by our premier program sponsor, the international law firm of Baker Botts. For more than 100 years, Baker Botts has been supporting, promoting, and elevating women in the legal profession, including their latest partnership class, which is 58% women. Now, it's going to be my privilege to introduce Dr. Margaret Sampson today, who will introduce our program and speakers. Dr. Sampson is herself an intellectual property partner at Baker Botts' Austin office, but she also happens to have a PhD in molecular and human genetics, as luck would have it. That degree is from the Baylor College of Medicine. And at Baker Botts, she has a global strategic intellectual property transaction and patent counseling practice, where she's focused in the areas of life sciences, pharmaceuticals, research tools, and medical devices. Dr. Sampson's intellectual property and technology clients turn to her, for example, regarding evaluating, structuring, negotiating, and documenting major transactions. Her scientific background is in molecular genetics, stem cell research, and recombinant DNA. Dr. Sampson has earned numerous accolades throughout her career, including being named among best lawyers and super lawyers. Dr. Sampson, over to you.
Thank you, Susan, for that kind introduction. It's an honor to be here, particularly today, International Women's Day, to delve into the work of one of the most cutting-edge and boundary-breaking women in science of the 21st century, Dr. Jennifer Doudna. Her pioneering discovery of the power of CRISPR-Cas9 technology, for which she received a Nobel Prize, represents both a significant scientific revolution in our lifetimes, but also raises equally significant moral dilemmas. As you will hear today, while there are many important moments in Dr. Doudna's life and work, one example in particular stood out to me. When she was young, Dr. Doudna read the book, The Double Helix, James Watson's account of how he and Francis Crick discovered the structure of DNA. Being International Women's Day, let's also take a moment to remember Rosalind Franklin here and her contribution to that discovery. I bring this up to say that books can have a powerful impact on young people who have an interest in science, particularly for young women who can read about women who have made amazing breakthrough scientific discoveries. The Codebreaker is such a book. And that is why it is my great pleasure to introduce Walter Isaacson, the author of The Codebreaker, and Dr. Helene Gayle. Walter Isaacson's historian's eye brings to life the biographies of the world's greatest minds of our time and their influence on the global stage beyond their professions. He tells Dr. Doudna's story as a scientific thriller and what it took for her to defy the odds as a woman in a male-dominated field. It is not an exaggeration to say that her story moves from the origins of life to the future of our species and carries the urgency of meeting the crises we face today. Mr. Isaacson is a professor of history at Tulane and has been CEO of the Aspen Institute, chair of CNN, an editor of Time, and the author of biographies about Leonardo da Vinci, Steve Jobs, Albert Einstein, Benjamin Franklin, and Henry Kissinger, among other works. Welcome, Walter. It is also an honor to introduce Dr. Helene Gayle. I'm in awe of Dr. Gayle's distinguished career working on global and domestic public health issues, poverty alleviation, gender equality, and social justice. For almost a decade, she was president and CEO of CARE, a leading international humanitarian organization. An expert on global development, humanitarian and health issues, Dr. Gayle spent 20 years with the Center for Disease Control, working primarily on HIV/AIDS. She worked at the Bill and Melinda Gates Foundation, directing programs on global health issues. She also launched the McKinsey Social Initiative, a nonprofit that builds partnerships for social impact. Under her current leadership as the president and CEO of the Chicago Community Trust, one of the nation's oldest and largest community foundations, the Trust has adopted a new strategic focus on closing the racial and ethnic wealth gap in the Chicago area. Her extensive background led her to being asked by the National Academies of Science to help create the framework for the vaccine distribution being implemented today. Dr. Gayle earned her MD from the University of Pennsylvania and MPH from Johns Hopkins University. She has also received 18 honorary degrees and holds faculty appointments at the University of Washington and Emory University, and sits on public company and nonprofit boards across the country. Dr. Gayle, thank you for being here today.
Great. Margaret, thanks so much for the kind and generous introduction. And Walter, it's wonderful to be with you. And there's just so much we could talk about, but you know, I want to maybe cover a little bit about the book and writing it, a bit about CRISPR, and then, you know, a bit about how this technology really challenges us in many ways, and some of the issues that I think are very relevant for the board and the boardroom. So let me just start. You know, this is a wonderful coincidence that this book about a woman is coming out right at the time of International Women's Day. You've written about some incredible people over time. Why did her story really make such an impression? And why did you feel this was a story that needed to be written?
Well, you know, I've written about the physics revolution that dominated the first half of the 20th century, from Einstein's theories to the building of the atom bomb, and likewise the digital revolution, which was the second half of the 20th century, from the invention of the microchip, the computer, and the internet. I did that through Steve Jobs and through Ada Lovelace, the great woman innovator who helped launch the computer revolution. now I wanted to do the biotech revolution. As Margaret knows so well from her great work on the intellectual property involved in the biotech revolution, this is the revolution that will most change our time. It'll be more important even than the digital revolution, because besides hacking the code of digital codes and giving us things like iPhones, we'll be able to combine that with the ability to read and even rewrite the code of life, using our genetic code. So I was looking for a way into it. And as you know, RNA has turned out to be the more important molecule. RNA is at the heart of these vaccines we're all hoping to get. And RNA is at the heart of CRISPR, which is this gene editing technology. And so I was looking for a way into that story. Back in 2000, all the men in biology were kind of focused on DNA, the Human Genome Project, sequencing the human genome of DNA. But a group of women who had almost been excluded from the Human Genome Project a bit, there's a lot of alpha males running it, focused on RNA, and that was Jillian Banfield, Jennifer Doudna, Emmanuel Charpentier. I could go on. And it turns out that RNA, is not as famous as its sibling DNA, but like a lot of siblings with, famous brothers or sisters, it does more of the work. It actually takes the code and builds the protein in our cell, such as a mimic of the spike protein for coronavirus, if that's what we tell a vaccine we want to do. It also can cut DNA. And so that's what we do with gene editing tools. So Jennifer Doudna discovers the structure of RNA, discovers how it can replicate itself, and it was the molecule that begins life on the planet. And she had read the double helix and had studied Rosalind Franklin, who was the woman there who had done the work that allowed Watson and Crick to understand the structure of DNA. And so through her life, I get to look at RNA, and then she and Emmanuel Charpentier are the ones who invent this tool for editing our genes. And then finally, she decides she has to take on the moral issues, the humanity issues of how should we use this. Those of us who are in boardrooms like yourself and everybody else on this call know that even when you get, some product or some idea that's going to work, you do pause at a certain point and say, how can we make sure this does for good, but doesn't cause any harm?
Yeah, no, and I want to get into some of those issues, the ethics, and some of the things that she's now started devoting her life to. You touched on this a little bit. Her being a woman probably mattered in terms of how she worked. And I know throughout the book, there's a big emphasis on the team aspect of it. What did you learn about, kind of the process of how she went about this, and why maybe having her be the person who was fascinated by this made this happen perhaps in less time than had she been a man? What were the things that she brought to it in terms of the way that she collaborated and worked that may be a lesson as we think about diversity and why diversity matters in the boardroom and elsewhere?
Yes, I don't want to generalize, but I do tell the specific story in which she's a great team builder. And when I watched at how she built teams, she made sure that everybody who came into her lab or into the company she was working on met everybody else, and they got along, that they kind of clicked, that they were able to be very collegial with one another. And I said, well, some people I know who are great leaders, they don't like that. They're like Franklin Roosevelt or whatever. They like having creative tension. They like having people, with sharp elbows fighting each other because they think that leads perhaps to more innovation. She said, I get that totally, but that's not who I am. I believe in teamwork and collegiality and people having each other's back, working hand in glove instead of, always trying to best their own colleagues. And I think we need different ways of collegiality, different ways of competition. When you're on a board, you don't just look at who's the CEO, you look at the team a CEO has built. And each CEO has a different style. Sometimes they want creative tension. But in Jennifer's case, she wanted collegiality. And that does lead with her working in a transatlantic collaboration with Emmanuel Charpentier, but also graduate students who are in Vienna and one up in Sweden and other places. They're able to collaborate, working 24 hours a day because they're all in different time zones, to win the race to discover how CRISPR works as a gene editing tool.
So I know that when you write a book, you are usually a bit of a different person at the end of it than you were going into it. Just from a personal perspective, what are some of the things that really struck you, impressed you, and you thought differently about as a result of writing the book?
Well, I was a little bit intimidated by, science and biology. I think we all are, unless we're scientists or people like Margaret who, have PhDs in biology. But what I found when I went to Jennifer's lab was after 2 days, I was able to edit human cells using CRISPR. I certainly had two graduate students helping me, but I realized that this is a technology that's rather simple, and it's simple to explain even in the book. There's not a whole lot of, science in the book. It's about just discovery of simple things that even bacteria know how to do, and they're not much smarter than we are. So that was particularly interesting. But another thing was the ethical evolution that I went through and that Jennifer Doudna went through as well.
Mm-hmm.
Because in the book, but also while reporting the book, I'm almost hand in hand with her as our views change, as new things happen. And just like Jennifer, I was a little bit resistant to the notion of, well, let's do gene editing, even to fight diseases. That seemed like messing with nature. But when coronavirus came along, I realized, every species, great and small, use all the tricks in their toolbox and all their wiles in order to become healthier and survive. And so should we as a species. That's why we developed these RNA vaccines that tell our cells how to build proteins that'll make us immune to the coronavirus. And it's also when she started seeing children of people with, genetic conditions, people with sickle cell, people with cystic fibrosis or Tay-Sachs.
Huntington's, yeah.
Huntington's, which is the most god-awful disease you can possibly imagine. And these people are saying, can't you help? Can't you help? And this technology will indeed help. It's already cured people of sickle cell this past year. It will help. And Jennifer started to say, well, I used to worry that it was immoral maybe to use this technology too fast. But now I worry that it's immoral not to use it when we have such things that we can help cure. So it gave me an open mind, which is what the scientific method is supposed to do, which is my thinking, my theories, they changed as I got new evidence. It's something, by the way,
So
we aren't doing very well in our politics these days.
no, we're not, but hopefully messages like this and the importance of science will once again be something that we all believe in and trust in. You mentioned that you now can do gene editing, and you describe CRISPR very clearly in the book. Could you just give a simple description of it so everybody knows what this method is and why it's so important?
It starts with bacteria, which for more than 1 billion years have been fighting viruses just like we do. In fact, they have had horrible battles with viruses. And what they learned to do was to take a mugshot of a virus that attacks them. In other words, a tiny, tiny snippet of the genetic code of that virus. And they put it into their own DNA in these clustered repeated sequences, now known as CRISPRs. And so when the virus attacks that bacteria again, the bacteria is able to use the mugshot, spot the virus, and chop up its genetic code. What Jennifer Doudna, Emmanuel Charpentier, and the others did is said, okay, we can use that technique to chop up our own DNA at a target that we pick. And so that's all CRISPR is a simple molecule. It has a guide RNA that says, here's the piece of genetic code I'm looking for. And it's got a scissors known as an enzyme. And that guide RNA and the scissors go to a spot in our genetic code and say, that's a sickle cell mutation, chop it out. Or that's a mutation for Huntington's, chop it out. And eventually we can do more complex edits, but that's all it is.
Yeah, no, it's fascinating. And the fact that we're learning this from bacteria, that bacteria are teaching humans.
Nature is beautiful that way, isn't it?
Yes, yes. And I think you said that in the book, or she says that in the book, nature is beautiful. And I think that, yes, this idea that if we just listen to nature, there are more and more things that we will actually find out. You mentioned and kind of alluded to some of the ethics. And, one of the things that she has shifted to Dr. Doudna is to really talk much more about the ethics of this, the governance structures, how we should be thinking about this. And I think you said something like, if and when we do gene editing, this will be one of the most consequential things for the 21st century. Talk a bit about, some of the ethical dilemmas and, what's even almost like a pathway. Everybody worries about, are we going to be doing designer babies tomorrow? But I think you've thought about it in a sequential sense. So say a bit about your thinking of the applicability of this and how we should be thinking of this as a society and its usefulness.
Sure. Right after Jennifer Doudna invented this technology, she had a nightmare in which somebody said, I want to learn about it. She goes in the room to meet the person. It turns out to be Hitler. And she says, okay, now we have to gather people to figure out how do we ethically use this. And through the book, I go with her and many other great thinkers, religious leaders, ethicists, and say, let's go step by step, because it's a slippery slope. But all slopes are slippery. In order to navigate a slippery slope, it's best to go step by step, preferably hand in hand, and to do it cautiously. So I start by saying, let's look at what I think are the easier cases. And by the way, I don't try to preach in this book. I just try to make sure the reader can say, hey, it's not up to the scientists, it's not up to the politicians, it's up to all of us to figure this out. So we go through the easier cases, such as Huntington's. As you said, Helene, that's a brutal, horrible disease. So yeah, we would probably want to fix that. And secondly, you do sickle cell and you do cystic fibrosis, simple things like that. And you'd also think, I would, that it's fine to do it in a living patient, like Victoria Gray, a Mississippi woman. Last year, she gave permission for her cells to be edited using CRISPR, and she's been cured of sickle cell. But there's a kid in the book, David Sanchez, who also has sickle cell. And the doctor says, we can edit your reproductive cells so your children and their children won't have sickle cell. He said, well, that's great, but maybe it should be up to the child before you do that. And it makes you think, okay, when you do it in a way that's inheritable, when you're making edits that'll be passed down from generation to generation, that's a line we have to pause before we cross. Another line that I think we have to pause at is, we want to fix bad genetic conditions. We want to cure diseases. But I think there's a line, although it's a blurry one, between curing a disease and making an enhancement. In other words, if somebody has predisposition to Alzheimer's, that's a pretty brutal thing. And if you could fix the gene so that they wouldn't get Alzheimer's, you'd probably do it. But if you can fix that, you can also add to memory. You can make a kid's memory better. And so that's sort of an enhancement. And I think we have to be careful to do things that are medically called for, but not do enhancements, or at least let's wait a few decades and think this through.
Yeah, so it leads to kind of the question of who should make those decisions. And, you allude to, the fact that our politics right now are a bit of a mess, and we are very divisive, and people have very extreme differences in the way they think about it. So, how do we think about who makes these decisions? What's the right governance structure? How do we evolve and make sure that we're thinking about this in a way that we don't go beyond a point of no return, and really think about this in the broader context, and make sure that we're thinking about it with the people's best interest in mind? What's the best way of thinking about that?
Well, I like the fact that you say we, because I do think it is we, meaning you and me and everybody listening right now. We should all be a part of this. We can't just say, let's let the scientists decide, or let's let the politicians decide. And that's what this book is about, which is helping people discover how easy and simple this technology is, how beautiful it is, and helping to cure us, but also how we should think through step by step what should be done. And once we as a society try to work out, just some sense of consensus, then I think we have regulatory bodies in both, countries, such as the FDA in the United States, that has to approve any medical procedure. But Jennifer Doudna has been able to get the science academies around the world, including China, including all the countries of Europe and Britain and us, so that the scientists say, all right, let's figure out what rules we would have. And I think it's important that in those discussions, and Jennifer Doudna has done this, that it's not just scientists, and it's not just politicians, but you have religious and spiritual leaders. You have ordinary citizens. And one of the voices I think has been missing, because everybody's cautious about gene editing, is that in the last two international summits, there are all sorts of ethicists saying, whoa, don't go there. I also think you need patient advocates. You need parents. You need parents of kids who have some of these genetic diseases, because, as much as we want to tap on the brakes, we got to hear the voices of people who say, my kid, he's got a degenerative congenital disease. She's going to die in 10 years, a horrible death. Can't you help save her between now and then? And so I think we want patient and parents on the thinking committees as well.
Yeah, critical, totally. You alluded to China a few times, and many people followed the designer baby and the situation in China where the babies where they made them susceptible to HIV and AIDS. And I think a lot of people felt like that was a bridge too soon, too far. Could you talk about that a little bit, and how we are comfortable that the globe is going to be working together as we think about what the right use of this technology?
That Chinese scientist sort of did it unauthorized, wasn't a great researcher. In fact, it was a sloppy use of genetic editing for the embryos of what turned out to be two twin girls. The silver lining there is that the scientific and the policy communities coalesced around, wait, that was an inheritable edit made before we were ready to do so. So China, he got tried. He's sentenced to 3 years in jail for doing that type of experiment. So I think even whether it's China, the United States, or Europe, there's a general consensus that we do not now make inheritable gene edits. One of the leaders in trying to have a moratorium on inheritable edits is Eric Lander, and he's just become the chief science advisor to President Biden. So I think we're on the right track in thinking this through. I'm not quite hearing you, Helene.
Now, yeah.
Yep.
All right.
Sorry.
They said I was having a little mic problems. So let me move to some of the issues around the product itself and the commercialization. One of the things you talked a lot about the importance of basic science and basic discovery, and clearly this was incredible basic science work that was done. But now there's a lot of focus on commercialization. Could you talk a bit about that process and some of the challenges even there as people have rushed to commercialize the CRISPR technology?
Well, let me start with my own bias, which is commercialization is a good thing, This is what we want. We want basic science to move from the bench, meaning the lab bench, to the bedside, meaning to the patient. And that only works if you have sort of a I call it a triple helix, a triple strand, which is government funding of basic research in university labs where they're doing it, and corporations to help commercialize and to use the intellectual property. That's what Baker and Botts and Margaret have done. Eldora Ellison happens to be, somebody doing the intellectual property for Jennifer Doudna and her team in Washington. And I think it's important that we realize that discovery should lead to intellectual property so that we can fund. I mean, Jennifer Doudna's lab or Feng Zhang's the Broad Institute, they're funded in a large part by the discoveries being made. But also scientists, and this is something we all learn in the boardroom, is not all one or the other. Scientists know that the main purpose is to help humanity. And so, for example, Feng Zhang at the Broad Institute is engaged in a patent battle against Jennifer Doudna and Emmanuel Charpentier. It's a pretty bitter battle. It's gone on for a long time. But when they both turned their attention a year ago to the spreading coronavirus crisis, they both rushed to make discoveries because they're competitive. But as soon as they did, they published them on these open servers that are used today to publish science. And they said, we're putting this out there so people can build on it and use these discoveries without worry about intellectual property right now to help fight COVID. So it's that balance we all do in the boardroom and we all do in our lives between, yes, we're doing something because, we're trying to make a living out of it or we're trying to fund more research, but we're also doing it for the common good. And no place else more than in science, and this book is all about that, do we look at how people weave together the common good, commercial success, and scientific victories.
So you mentioned a few times how this has impacted what we're battling now, coronavirus, COVID-19. Could you say a bit more about how this technology and her focus on RNA really made it possible for us to do things in record time that we would not have been able to do otherwise?
Yeah, well, if there's a hero to my book besides Jennifer Doudna and her colleagues, it's the molecule of RNA that we've talked about, which is a molecule that can do many things, two of which are very important. One is its basic function in biology is called messenger RNA. It takes a message from our genetic code and goes to the region of the cell in which we build proteins, and it builds a specified protein. That turns out to be how the mRNA or messenger RNA vaccines of Pfizer and BioNTech and Moderna are done. So the basic science of RNA, which Jennifer Doudna contributed to in the 1990s as a graduate student and then with her structure of RNA research, that's an important part of it. Secondly, and more specifically, CRISPR, this gene editing tool, which uses RNA as a guide to say, I want to cut a genetic code at this spot. That can be done in a way that helps us detect the coronavirus very well. Now we use, those of you who've tried to get, COVID tests, even now it's a bit of a mess and it takes a while. But with these CRISPR tests that are just coming online right now, these are simple things with a bit of saliva. It instantly detects whether or not the genetic code of a virus is there. And it can be reprogrammed to detect anything, including the genetic code of, say, a flu virus or strep throat or a cancer tumor or a bacterial infection. So these will be home testing kits where you can test for all those things. And entrepreneurs will build apps on top of it, just like they built apps on top of the iPhone and gave us things like Uber. They'll say, okay, I'm going to put an app on this home testing kit that will do our gut microbiome and tell us what bacteria is in our gut and whether we should eat more yogurt or something. So these are the type of things in which these new technologies are being used to fight the coronavirus, but more importantly, they can be reprogrammed to do anything we need them to do that involves organisms that have genetic material, which basically means all organisms.
So it's great to hear your science optimism, because I like you believe that there's so much that if we look into the future that we will be able to do. And I think it is balancing some of these, how we think about the context, society, the moral dilemmas and all the rest. But I think there's such a bright future out there. I know I'm going to need to turn this over. Let me just ask one last question. Where were you when the Nobel Prize was announced? And, how did that make you feel?
So I was here in New Orleans, where we live, and I thought it's a bit early for CRISPR to be the subject of the Nobel Prize. I mean, the day before they had given the physics prize to Sir Roger Penrose for a discovery about black holes that he had made 50 years ago. So usually it takes the Nobel Committee a while to say, all right, this is worthy. But just in case, I set my alarm for 4 a.m. so I could watch the live stream from Stockholm. And boy, my wife is asleep. I'm watching the live stream, and boom, they announce it's for CRISPR, for rewriting the code of life.
Wow.
The secretary of the Nobel Committee says, and it goes to Jennifer Doudna and Emmanuel Charpentier.
Wow.
So I yell and scream. I realize it's only 2 a.m. in Berkeley, where Jennifer is. So I wait until a little bit later that day and call her. And she said she had slept through it. And she had slept through the phone ringing with the phone calls from
Wow.
Stockholm. And it was only about 40 minutes later that a reporter woke her up with her phone vibrating. So I got to find out before she did.
That's amazing. Well, thank you. And I could go on and on and on, but
then Judy will get
take
mad at
over
us.
and the audience and get some of the audience questions in. Thanks so much. This has been a wonderful
Elaine,
conversation.
I always love being with you. You're the greatest.
Likewise.
Well, I have to say our audience has been very active posting questions, and I want to ask, actually, prerogative, the first question, which is, what was the kind of the moment that you knew Dr. Doudna would be your next, the next subject of a book, and how was it writing about a living person versus someone who has passed away?
Yeah, I had been thinking, as I said, that I wanted to write about the biotech revolution. And I got to know Jennifer Doudna, whatever, 6, 7 years ago. She came to the Aspen Institute. I interviewed her on stage. And I've written some books that are collaborative books, like The Innovators, that don't have a central character, or The Wise Man. But and sometimes I write it through one person, a biography. And I was thinking this would be a combination. It would be about one person as the narrative thread, but all the other colorful cast of characters. And I think after spending time with her in Aspen and looking at her entire career, I realized she was the person who spanned everything from reading the double helix in middle school to helping figure out COVID and the ethical issues in the past few years. And she became my central character.
And you have alluded and talked about the nature of cooperation and the spirit of collaboration. And we have a question about whether you can apply lessons to business or other areas beyond science in terms of team dynamics, leadership, and organizations.
All of my books try to explore that very important question. I once asked Steve Jobs, late in life, his life, what was the best product he ever made? And I thought he'd say maybe the original Macintosh or maybe the iPhone. He said, no, making products like that is hard. But what's particularly important is making a team that can continue to make products like that. And he said, the best thing I ever did was make the team at Apple. And so in that book, I look at how you have Johnny Ive, a great designer, but somebody who's a, great industrial engineer who can take Johnny Ive's wacky ideas and see if you can make them work. And somebody like Eddie Q, who handles things like the content. So I began to see that teamwork was the thing. And when I wrote about Benjamin Franklin a while back, that may be one of the great teams ever put together, which is the whole team of our founders and their families. But you needed a person of great rectitude like George Washington. You needed really smart people like Jefferson and Madison. You needed people of high passion like, Samuel Adams and his cousin John. But you also needed somebody who could make teams, and that's what Ben Franklin did. And so when I wrote about Jennifer Doudna, I didn't just write about her scientific ability. I wrote about her collaborative and team-making ability, and most important, how to be collaborative and competitive at the same time. Anybody who's on a business board knows, this notion of a frenemy or a co-opetition or something where where you're Apple and you're cooperating half the time with Microsoft and you're competing half the time. That's the hardest thing to do. We all know how to collaborate and we probably all know how to compete. But what Jennifer Doudna's life story teaches us is how do you interweave the two?
Mm, mm. And there is a really provocative question about the distinction between curing a disease and making a medical enhancement. Are there any, even at this stage, generally accepted principles upon which directors can and should rely on to make this distinction for their companies?
Yeah, it's a blurry distinction because, as I said, you can help somebody with memory loss, but the same type of thing can help enhance memory, and where do you decide what's an enhancement? If there's a child that has a particular gene and that child's going to grow up to be 4'10", and you fix it so the child will be a typical height, I should say, like 5'6", 7, 8, that's probably curing a genetic defect. But if you take a child who's 5'4", a little bit shorter, and you add 8 inches to him or her, that gets to be an enhancement. And it's all the same when it comes to gene editing. It's hard because even I have in my book the notion of deaf families. And some of them feel that curing deafness is a bad phrase, that deafness is not a disability, that deafness is, part of who they are, and society should accept people who are hearing enabled and people who aren't. So the question is that an enhancement or is that a fix of a genetic defect? By the way, don't go buying my book thinking there's an answers to all these questions at the very end. We have to walk through this together. And so I do look at, and I leave it to you to read the book, because it's fun to go through it. I do think we can look at what you could call species typical. That's not quite the same as normal because normal makes it sound people who aren't that way are abnormal. But if you're 5'7" or 5'8", or you're within 6 inches either way, you could say that's species typical. And if you're, likewise IQ, if you're at a certain level, I don't know what it is, within 20 or 30 points, that's species typical. So that's one way we could try to take this pretty blurry line between enhancements and curing genetic defects and say, let's not do anything where we take somebody who is typical of the species in a particular trait and try to make them better. But if somebody's way below species typical and it's harmful to their ability to fulfill their life goals, then that might be a moral reason to fix that condition and bring them to the point where they're closer to species typical. That sounds pretty technical, but we can all translate that as we have to do every day in our lives and say, all right, that's a guideline. It may not be a perfect metric, but it's a pretty good guideline we should start with.
So how do we how concerned should we be about biohacking? You know, just using what has happened in the cybersecurity environment over the last 25 years and the escalation of tactics and techniques. How do you think about that?
Well, there's a character in my book named Josiah Zayner. He pops up 4 or 5 times. He's a little bit like Puck in A Midsummer Night's Dream. He's the one who say, what fools these mortals be. And he's a biohacker. He has a PhD in biology, but he works out of his garage, and he makes CRISPR that you can buy online. He's even used CRISPR to change the gene for myostatin control, which means he could get bigger muscle mass in theory. And he did it once. He injected himself in a live stream video. He made a DNA vaccine for COVID and injected himself in a live stream video. He even sent me some of the DNA vaccine he made and said I could inject it. No, I'm not Puck. I'm not the wise fool or the fool. I didn't do that. But I kind of let the reader figure out, all right, it's like Puck in A Midsummer's Night Dream. Is he good? Yeah, in many ways. He pushes us forward. As Steve Jobs would say, it's the people who are crazy enough to think they can change the world are the ones who do. So there's a room for citizen science, and we shouldn't sort of be afraid of people being involved, even when it's biohacking. On the other hand, no, I ain't gonna take Josiah Zayner's DNA vaccine when he mails it to me.
But also, it strikes me how simple this gene editing technique is. Is it really that simple?
Yes, it is simple enough that any graduate student in biology in a lab could easily edit human genes. And if you're a pretty good enough undergraduate, you could probably do it. As I said, I could do it after 2 days with 2 graduate students. You can order what are called the reagents, meaning the material, the liquids and all you need. You can order it online. You can order it from Josiah Zayner. The Odin, ODIN, is his .com, is his biohacking place, and he'll mail you, CRISPR kits. Mainly you could use it to make super frogs. You should not use it on yourself. So it's easy enough that it's not like building an atom bomb where we can regulate it very easily because nobody's going to build an atom bomb in their basement or their garage. And the hard part is not the editing of the cell, but the delivery mechanism to get it into an early stage embryo and implant that in an IVF clinic. Or there's CRISPR treatments that can kill coronavirus, but getting it delivered into the cells of your lung where the coronavirus may be doing the most damage, that's the hard part.
So here's another interesting question. How do you think we should balance the societal benefits of an open source approach to biological platforms to drive innovation with the desire of private companies to create and extract value by investing in their own scientific research?
Well, you might not be surprised to know that I think that there's a benefit in both methods and both methods coexisting. Just like in the computer world, we have open source software like a new Linux and, the various open source operating systems like Linux. And we also have Microsoft Windows or proprietary operating system. And when both exist, there's sort of a competition between the two, so that if there's too much hoarding of intellectual property, it's sort of a check and a balance to have some open source. But if you have all open source, then there's not going to be a business model for funding research. And I look at, let's take COVID vaccines, for example. And people say, Pfizer and BioNTech invented one, and Moderna invented one, and Johnson & Johnson did. And now they should make them all open source. They shouldn't profit from it. Well, that's crazy. I mean, I'm not sure you would have had those huge labs doing it if they couldn't make some money off it. Now they've licensed it in a very generous way so that everybody can get the vaccine. But you look at the research and you look at a company like Merck, which is really good. It spent millions of dollars developing two vaccines that didn't end up working. So people have to spend money, not just on the drugs that work, they have to sometimes try things that don't work. So I'm somebody who actually believes, and this is going to get me in an argument with some of my friends, that pharmaceutical companies and Berkeley and MIT and Harvard, when they come up with great tools, we want there not only to be incentives, but to be funding for it.
So I'm curious, based on this question, whether you're familiar with the Human Genome Discovery at UCSC.
Well, University of California, San Francisco is part of Jennifer Doudna's.
Corollaries with the commercialization of CRISPR and this discovery at the University of California, San Francisco.
I've spent a lot of time, including with Joseph Dinambonami and others at UCSF, Weissman. I can name maybe 24 discoveries that have been involved, including anti-CRISPR, which is a way of turning CRISPR off if you make a mistake. I'm not sure which one you're referring to, but UCSF is in a partnership with Berkeley. They're both part of the UCal system. They're doing a lot together.
And then do you think that current laws adequately protect genetic privacy? Like what potentially could go wrong?
Yes, I think they do. And I think HIPAA, if anything, once again, I'm going to be controversial here. I think HIPAA in some ways goes too far. I'm in favor of a program that Eric Lander has initiated, and which now that he's Biden's science advisor may go further, called Count Me In. Is if you're a patient, and let's say you've had cancer, and they've sequenced your genome, and they've sequenced the tumor, and they've sequenced all the drugs that are using it, you should be able to sign, just as you are an organ donor, be able to sign up and say, count me in. Put all of my genetic findings and materials and all of the tests and the sequence of my own gene and put it in a database. Keep me anonymous, but use the material. And I think sometimes, I can get if I can drive through, the West Bank of, Palestinian territories and go to a ATM machine and get up my financial records. But if I have a toothache, I can't get my medical records. So yeah, we have to prevent people from having, but people send in their saliva to 23andMe and, have their genome looked at, and that's not very private, just so you know. So I think, we volunteer sometimes to give up our privacy, but generally, if you go to a hospital and they do a genetic markup of you, it's pretty well guarded, your privacy.
And now I'm being taken to task for not asking the questions with the most thumbs up. So I'm scrolling through for one of the first questions that was asked about who should own the capability for CRISPR. To the ethical question, should a company be making these decisions? Or if so, what's the role of the board in making decisions? Like these really, ethical questions.
Well, first of all, I think the first line of, I'll say, defense is the government agencies. I mean, the FDA will either approve or not approve, say, the treatment for sickle cell that was successful this past year. And it may at some point approve or disapprove some other form of gene editing for various diseases. So I tend to think the FDA is actually a pretty good agency. They're pretty smart. They know what they're doing. So that should be the first line. I think that this is no different for a corporation than anything that a corporation, any product it makes. If you're on the Facebook board, you got to start asking questions about how is our product being used? And if, And I worry more sometimes about social media and digital tech companies than I do about medical companies at the moment. But any board member that doesn't ask what's the social benefit and what's good. And by the way, that should be asked even now because the allocation of our resources, you know, to find baldness cures is probably, you know, hundreds of times more than to find a cure for sickle cell because that's where the money is. So these are not just simple questions of do you use this discovery this way or that way. It's where do we put our time, energy, and our IQ points? Do we do it for helping humanity? And I mean, you know, if anybody knows this, Helene knows this from her days at CARE, which is how do we make sure that around the world, the people who need, you know, products and health and everything else are getting it equitably? That should all be part of our thinking process when we're saying, why are we focusing our energies on this?
And that's actually in this question about how can science be made available for every person? Is there a risk of gene editing becoming only an option for the wealthy?
Oh, is there a risk? A total risk, because there'll be, it's like at a genetic supermarket. If you imagine, you know, in science fiction or even coming up soon, you get a little, you know, shopping list. Do you want kid taller, blonder, whatever, you know, darker haired, memory, you know, things like that in the future. And if these offerings at the genetic supermarket aren't free, and at the moment they aren't going to be, is that going to take the inequality that exists in our society and kick it up to a new quantum level? In fact, encode it into our very genes. That is one of the huge risks that Jennifer Doudna is addressing, but we all have to address, which is when we decide we're going to allow a gene editing or genetic technology to be used, we have to, you know, among the first things we have to ask is, will it be equitable? Will it increase the inclusiveness of society? Or will it divide us further as a society? And I would say that's in the top 3 or 4 ethical litmus tests I would give.
And we all need to be citizen scientists. I see that my colleague has joined me here. So I am going to thank you, Walter, for answering our audience questions and turn it over to Susan Paley.
Thanks, Judy. And to Walter and Helene, wow, you've given us a great deal to think about, not just in our roles as directors on boards, but also as intellectually curious citizens of the world. Clearly, biotech and ethics, innovation and science are top of mind, in particular today. And Walter, you may have inadvertently perhaps brought something else to mind with that comment from Steve Jobs. It may be less glamorous than the innovation and the science and tech, but just as critical, having the right team. And I might argue the right culture organizationally to support that research and that product development is key.
And let me, if I can add one more thing, as Steve Jobs would say, part of building the right teams is having the right diversity. Nobody knows this better than NACD. And there has not been a great deal of diversity in the innovations of the digital revolution. Whatever you say about Steve Jobs getting a good team, they tended, like most tech companies, to be all male and mostly white. And the cool thing about the biotech revolution is that women have been very much included. In fact, 60% of the people now studying biology are women, undergraduates and graduate students. So it's one that's become very inclusive of women, as indeed Emmanuel Charpentier, Jennifer Doudna, and my book show. However, as I went around, I went to the conferences, I went to all the labs, I saw a whole lot of women, you know, at least half of the women, it seemed, in every lab and every conference, I mean, were women. But I didn't see a lot of Blacks or people of color. And we don't want another innovation revolution that was like the digital revolution, in which people of color and minorities are left out. And so that's why I think we have to focus too on making sure that the biosciences are very inclusive in all sorts of ways.
Indeed.
Because
Thank
it's
you for that
particularly
comment.
important because it's our society. We're not even just talking about our iPhones. We're talking about our species and all of its great diversity in our lives. And so it's got to be inclusive.
A perfect
And I would
comment.
just add to that, it means that we're going to be asking the right questions as well, because I think we don't get the right answers if we don't ask the right questions, and that the right questions for the whole society are going to be asked by the collective. And I think you focused on the we before, and I think this notion of why it's so important that we include the we as we're thinking about who's asking questions and how those answers, once we get them, are used for the good of all society. So
Thank you. Yeah, I think these are such critical matters. And I want to thank you both for those closing comments and for that fantastic event that you just helped us as a masterclass in these matters, and for your continued good work and board leadership. We can't wait, Walter, to see what you're going to write about next.
Neither can I.
So audience, if you missed something in the rapid fire of today's event, don't worry. As I mentioned, it has been recorded. It is going to be distributed so you can share it with your colleagues, and that'll go to all attendees. A listing of upcoming NAC chapter programs will be emailed to you directly and included in the chat box as well at the same time. And a reminder that our members do matter to us, and our goal is to deliver content that meets and exceeds your needs. So audience, we hope you'll take time to complete the program evaluation that we're going to send to you. We love hearing about topic suggestions from our members. And if you are a special guest today and not yet a member, if you're curious about membership with NACD, please reply to our email when we send it to you. We would be delighted to answer your questions. Thank you all again for joining us. We can't wait to see you at a future NACD program. In the meantime, stay well, stay safe, and have a good evening.